In this video, we're going to look at area under a curve. And we're going to start, and we're going to look at how integration can do this for us. We're going to start with just a straight line here. Let's call it y is equal to x. And let's call this here the point 6, 6. Now, from your basic knowledge of maths, you can tell the area of this triangle is half the base by the height, which is equal to half of 36, 6 by 6, which is 18, and we'll write square units, or units squared. So let's have a look. If we integrate y is equal to x, or we integrate x, we're going to get x squared over 2. Now if I put my bands in here between 0 and 6, we put the highest number on top and the lowest number on the bottom. As you've seen before, this becomes a bracket, and we're going to get 6 squared over 2 minus 0 squared over 2, which is going to give me 36 over 2, which is equal to 18 square units. So this works for curves, it works for areas between curves, and we're going to look at a few questions now that deal with area under a graph. So what about this one? We're given the curve y is equal to x squared plus 2, and we're just looking at a portion of it here, and we're asked to find the area of this shaded region, which is the area under the curve, the x-axis, and the lines x equal to 2 and x is equal to 4 in this case. So we're going to integrate between 4 and 2, x squared plus 2 dx. So we're going to get x cubed over 3 plus 2x between 4 and 2. So we're going to get 4 cubed over 3 plus 2 times 4 minus 2 cubed over 3 plus 2 times 2. And what does this give us? 64 over 3 plus 8, which is 24 over 3, minus 8 over 3 plus 4, which is 12 over 3. So we're going to get 88 over 3 minus 20 over 3, which is equal to 68 over 3 square units, or units squared. In this question, we will use the trapezoidal rule to estimate the area, because the trap rule is an estimation of the curve y is equal to x squared plus 1 from x equal to 1 to x equal to 4. So let's put in some lines here. We can see here the width between them is 1, and we need the approximate heights. Well, we get the exact heights using putting in our values at 1. At x equal to 1, you can see that y is equal to 0, 1 minus 1. At x equal to 2, y is equal to 4 minus 1, which is 3. At x equal to 3, y is equal to 9 minus 1, which is 8. And at x equal to 4, y is equal to 16 minus 1, which is 15. So using the trapezoidal rule, h over 2, so the width of the band is the number I put over 2, so 1 over 2. By the first plus the last, the height of these, 0 and 15. 0 plus 15, plus twice the rest added together, which is twice my 3 plus 8. It's going to give me half of 15 plus twice 11, which is 22. So half of 37, which is 18.5 units squared. So this is an estimation. Now integration will give us the exact value between 4 and 1 of x squared minus 1 dx. So that's going to be equal to x cubed over 3 minus x between 4 and 1. And if we put these values in, we're going to get 4 cubed over 3 minus 4 minus 1 over 3, or 1 cubed over 3 minus 1, which is going to give 64 over 3 minus 12 over 3 minus, now we're going to get a minus value in here, minus 2 over 3, which is going to become a plus. So we're going to get 54 over 3 plus 2 over 3, which is 18 2/3 sorry, 52 over 3, just double check it, 52 over 3 plus 2 over 3, which is just around 54 over 3, which is 18. So you can see the difference, very small. Trapezoidal rule is a good approximation though. If you were asked for the percentage difference, 0.5 difference over what it should have been times 100. Question that has come up in Leaving Cert in the past. In this question, you're asked to find the area enclosed between the curve y is equal to cos x, the x-axis and the y-axis, and the line x is equal to pi over 3, which is the x value along here. So between 0 and pi over 3. So if we integrate cos x between pi over 3 and 0, if we integrate cos x, we get sin x, because if we differentiate sin x, we get cos x. So between pi over 3 and 0, we're going to get the sine of pi over 3, which is sine of 60, minus the sine of 0, which is 0. Sine of 60 is root 3 over 2. Sine of 0 is 0. So our answer is just root 3 over 2 units squared. In this question, find the area of the shaded area. I've left out the rest of the dialogue, but between the x-axis and y-axis, between 0 and the natural log of 5, or when x is equal to the line x equals the natural log of 5. So if we integrate e to the power of x between the natural log of 5 and 0, differentiate e to the power of x, we get e to the power of x, so the same in reverse. So we're going to get e to the power of x between the natural log of 5 and 0. So we have e to the power of the natural log of 5, which is just 5 obviously, and e to the power of 0. Anything to the power of 0 is equal to 1, so we get 4 square units. In this question, we're given the curve y is equal to e to the power of minus x. You're asked to find the coordinates of the point PQ. So you can see here at this point in here at PQ, x is equal to 0. So y is equal to e to the power of 0, which is equal to 1. So it must be the point 0, 1. Find the area of the shaded area, or show the shaded area is 1 minus 1 over e to the power of t. So we need to integrate e to the power of minus x between t and 0. So we integrate e to the power of minus x, we're going to get 1 over a, 1 over minus 1 e to the power of minus x between t and 0, which is minus e to the minus x between t and 0. So that's going to give me minus e to the power of minus t, and then it's going to be minus e to the power of 0. So that's going to give me minus e to the power of minus t minus 1 plus 1, which is 1 minus e to the power of minus t, and e to the power of minus t is 1 over e to the power of t. And the third part, the limit of this area as t approaches infinity is 1 minus 1 over e to the power of infinity. So 1 over a massive number tends to 0, so we're just left with 1. So 1 is the area, and I should probably have written units squared beside that. Units squared, or just unit squared. In this question, we're given the curve y is equal to x cubed. To find p and q, we're given these values 1 and 2 on the x-axis. So at x equal to 1, y is equal to 1 cubed, which is 1. So that's the point. 1, 1. So p equals 1. And at q, x is equal to 2. So x equals 2, y is equal to 2 cubed, which is equal to 8. So that's the point 2, 8. So q is equal to 8. So find the area A1. So the area in here under the curve between 1 and 2. So we integrate x cubed between 1 and 2. We're going to get x to the power of 4 over 4 between 2 and 1, which is 2 to the power of 4 over 4 minus 1 over 4, or 1 to the power of 4 over 4. So that's 16 over 4, 4 minus a quarter, which is equal to 3 and a quarter. 3 and 3/4, 3.75 square units. Find the area A2. Now if you look at it sideways, this is the area under the curve with what y is equal to. So what is y equal to? Sorry, what x is equal to? Y is equal to x cubed. So x is equal to y to the power of a third. So we integrate y to the power of a third. We have our values here. We have the p and q. We have 1 and 8 between 8 and 1, we're going to get increase the power by 1, y to the power of 4/3 divided by 4/3, which is equal to 3y to the power of 4/3 over 4 between 8 and 1. So that's going to give me 3 times 8 to the power of 4/3 over 4 minus 3 times 1 to the power of 4/3 over 4. So 8 to the power of 4 is going to give me 4096, and the cube root of 4096 is 16. So 3 by 16 over 4 is going to give me 12 minus 3/4. So that's just going to be 11.25 square units. And there is another way to do it, which we'll look at now. So if we look, maybe an easier way to do it, if we look at the overall area is 8 by 2, which is 16. So we can take away this area, and the area we've already gotten, we'll be left with A2. So minus, this one here is 1 by 1. So minus 1. And the first answer we got was 3.75. So that's going to give us 16 minus 4.75, which is also 11.25 square units. So practice some more of these questions and perfect area under a curve.